Hello, everyone. Thank you for tuning in to this episode of the Amazic podcast. I'm Twain Taylor, editor at Amazic, and we bring you some of the latest and the greatest from the space of Kubernetes and cloud native. And that's what we're continuing to do even today. So if you like what you hear, go to our website and you'll find 2 years worth of similar conversations that we've done, more than 2 years, in fact. We've spoken to vendors of all sizes that are solving challenges across the stack when it comes to cloud native. So no matter what you're interested in, I'm sure you'll find something that that's useful and that could really help with your organization's cloud native journey. Today I have with me Ari Shotland, who is the VP of Engineering at Dragonfly DB, and their website is dragonflydb.io. So I'm looking forward to talking to him about all things in-memory databases. That's going to be today's focus: in-memory databases. That's their product. That's what they specialize in, and so we're going to dig in to really get to know what is Dragonfly's approach to in-memory databases. Hope you're excited. Let's get started with this conversation. Ari, thanks for joining us today. It's great to have you with us. Yeah, as we get started, I was wondering, Ari, if you could give us a little introduction about who you are, what you've done, and how you got to Dragonfly.
Yeah, sure. So thanks for having me. It's a pleasure. Yeah, I come from a computer science, software engineering background. I have my bachelor's and master's degrees in the Technion, which is the Israel Institute of Technology, and started my professional career at IBM Research around 20 years ago. And then in 2007, I had a privilege to join Google as one of the first employees here in Israel.
Oh, wow.
And
Nice.
that's also where I met Roman Gershman, that eventually turned to be the creator of Dragonfly and the co-founder and the CTO of Dragonfly DB. So I spent 11 years at Google and ended up running the infrastructure teams for the autocomplete service, powering most of Google's products like search and YouTube and maps and like a long tail of like smaller products. Then I had the opportunity to act as CTO for Plus 500. Plus 500 is a publicly traded, it's a public company in the B2C trading space. So over there, I had a great experience of like learning how kind of large scale online business works and being in charge of like all technological aspects of a large scale online product. So of course it's not as large scale as Google, but like the scope was much wider, from like everything from product to development and production and security and compliance. Yeah, and all that kind of gave me like the itch to go after like 0 to 1 startup experience and like building something from scratch. So yeah, that, and like after like 4 years plus 500, then my passes crossed with Roman again while I was looking for like again this like some startup experience. And yeah, Roman recently founded together with Oded Ponce Dragonfly DB, and yes, if I'm interested to come over and help building Dragonfly Cloud, which is the commercial managed cloud offering of Dragonfly. Yeah, so Dragonfly has like a source available community edition, which everyone can they can run. And Dragonfly Cloud is the commercial managed cloud offering on top of that core technology. Yeah, and here we are.
Neat, neat. All right, that's a cool intro. Nice to meet a fellow Zoogler. I was at Google India for a while back in the
Nice.
day, kind of around when you joined as well.
Cool.
Yeah, the focus today is in-memory databases. So I was wondering if we could get started talking about just at the top, what is an in-memory database and what are the different workloads and purposes that they're used for?
Yeah. Okay. So as the name suggests, in-memory database is about like they store the data in memory, and at least not like the primary purpose is not about like durability and like persistence of the data, but rather more of like ephemeral use cases, and kind of the trade-off is like what you gain by that is like performance and like better throughput and much lower latency, and all the use cases can kind of revolve around that. The use cases that require high throughput and very low latency. Now, if we like want to like talk about a few use cases, of course, like the most popular and obvious one is caching. So a typical use case would be you have like some relational database. It's typically like the bottleneck of your system, and then you will introduce a cache in front of it, typically in the form of in-memory data store. The most popular technology in that space is Redis, and also to less extent, but also quite popular is Memcached. Yeah, and we are like competing in that space. But there are also like many more diverse use cases. So for example, like with the transition to like stateless microservices, like if we're talking about Kubernetes, etc. So like, right, pods are like ephemeral, they're interchangeable, they come and go. So like you need some solution for your like state in a distributed system. So that's also like a common use case to solve like this state problem of this distributed system. And there are like more like job management queues with like a Redis backend. Now there's like lots of use cases around like the Gen AI trends for vector search and again like storage, storage for RAG for retrieval augmented generation systems. And it goes on, with like batch processing use cases or like large data pipelines that need like massive, read and write throughputs. Yeah, so it's really like a diverse space.
Yeah, that's a great definition of what is in memory and its use cases. Could you also extend a bit from the use cases and tell us more practically which kind of organizations and which kind of applications that need in memory the most frequently seen ones in terms of use cases, like the actual end user use cases, if you can explain some of those.
Yeah, so again, very diverse, from like large enterprises to small startups. Again, the caching scenario, of course, is like is is widely used. It does, of course, goes kind of hand in hand with a large scale, so you need to have like a meaningful workload. But even some smaller use cases like in gaming, like leaderboards is a very common use case for like very sorted sets. Or like if you use a job management queue. So again, it's really, really diverse. We at Dragonfly, we shine like for large workloads. Like the larger your workload, the brighter we shine and the more value that we provide.
Got it. Got it. So you mentioned that the key focus of in-memory is performance and speed over, let's say, the reliability or the consistency of the data. Can you dig in
Yeah,
a
it's
bit
all
more?
about persistency and durability, of course.
Yeah. Mm. Yeah.
It is reliable and consistent,
Okay. Okay.
but
Okay.
just not.
Okay. All right. Got it. Could you dig in and tell us a bit more about when it comes to performance, what are some of the key factors? Because like we see these key terms related to database performance, like throughput and latency. Can you explain, because performance can be a bit generic, break it down a bit more and explain what does performance mean when it comes to in-memory databases, and give us some of those details. What affects performance of in-memory databases?
Okay, so yeah, typically for in-memory database, you will have like two primary dimensions of performance, which is memory and CPU. Okay, so the CPU, like the more efficient your software is, and the more it can perform with like less cycles, it will be more performant. And on the memory space, so again, like the more optimized your data structure are, that can like store in memory kind of the same the same data in a like from a semantic perspective, but like you can then represent it in memory differently, right? And with different just different amount of bytes basically that you need for like for your items, for your entities. And now there's another dimension actually for performance here, which we should note is that how because like in modern hardware, like cloud hardware, so you get kind of those fixed boxes, right, from the cloud vendor. So it's also about how efficiently you're able to utilize that hardware. So that's like another aspect that again is a specific kind of problem that Dragonfly solve in that space, which we can like dive deeper into. Yeah, but in general, it's like how optimized are you with respect to CPU, with respect to memory, and like with respect to utilizing the available resources of your hardware.
Okay. Okay. Got it. Yeah, let's talk a bit more about the challenges. So what are some of the biggest challenges that organizations face when it comes to in-memory? You mentioned scaling as one of them earlier.
Yeah.
Talk a
Yeah.
bit more about the top challenges.
Yeah, so I think, as you said, I think like it's pretty much the same as like any other infrastructure, that basically how do you scale efficiently? I mean, most things works well when they're not stressed, and like you don't need to like scale them. But then like as you need to scale, so like how is the is the experience consistent? Okay, like do you get like roughly the same experience, same latency as you scale your workload? How costly is it to scale, right? What is how is the maintenance cost when you scale? So I think those are very like common for for infrastructure teams, as they like it's a very common challenge. Yeah, and this is like something that Dragonfly tries to solve in the in-memory space.
So are you saying,
Providing easily scalable in-memory data store, both in terms of hardware cost and operational cost.
Okay, okay, got it. And yeah, you mentioned like Redis is the most popular option out there. And yeah, I was wondering if, when you talk about small scale, a little bit of data over there, is the difference very minimal when you compare something like Redis to Dragonfly and all of the other options for in-memory databases? Are the differences very negligible? In other words, if you're starting out and your needs are not too big, are the differences negligible? And if your needs are bigger, you need to scale more. Is that when you need to really consider, do you want to go with Redis? Would you say that's accurate?
Yeah, even more so. But maybe it's a good time to like give a bit of background of like how Dragonfly differs from Redis.
Mhm.
Um, so Redis was created like I think more than 15 years ago,
Mhm.
and the world was quite different back then, and like cloud computing was in its infancy.
Yeah.
And back then, the Redis creator took a design decision uh, to make the software single-threaded. Okay, and with that, like you don't have any contention issues. You don't need to lock, like to synchronize any threads. You avoid locking and contentions overall, and you are indeed able to utilize like a single core very, very efficiently.
Mhm.
And indeed, Redis is a great tool for such workloads that like don't need to exceed the one core load.
Mhm.
Um, and But then, like, again, the world changed, and now, like, you have like very accessible loud server in the cloud. Okay, the workload sizes grew, to the hundred and terabytes to the 100 gigabytes and terabytes size of data. Those servers come with like plenty of cores, and then it doesn't really fit. And again, Redis is like widely popular. It's like really loved by developers. Okay, so we at Dragonfly, we very much acknowledge that like Redis as a product is great. Okay, so we maintain like the same API that developer love and use, but rebuilt like the engine from scratch using multi-threaded shared nothing architecture. Okay, and so now we go back to your original question. So of course, like if your workload is small and you only you can cope with just one core, so Redis will be even like more performant because it doesn't need to pay the overhead um, of of to pay the overhead of like synchronizing multiple threads. Um, but once you exceed that, okay, then like Dragonfly, that's when Dragonfly shines, and like our kind of novel implementation, while of course has an overhead of like synchronizing multiple threads, it's almost lockless and very efficient. Um, so yeah, of course, no free meals out there. There's always a trade-off. Um, but yeah, the Dragonfly is like is it's pretty efficient even with that overhead. Yeah.
All right, got it. Um, yeah, and so there's also other options. Or like I'm thinking of like organizations that are very heavily invested in AWS. Let's say AWS has their own uh, Redis
Yeah,
alternative
Elasticache. Yeah.
cache. Yeah, uh, you know, uh, s- yeah. So those things are also available. And how does Dragonfly, compare position itself next to something like Elastic Cache?
Yeah, so as you mentioned, Elasticache is basically, the managed cloud offering of AWS of Redis. Um, So it will be like the same, same comparison. And once once your workload, exceed the one core, then either you need some solution, either you need to start breaking, basically to start breaking up your workload, either by moving to a cluster architecture, which has its own complexities and limitation, and or breaking up your workload in the application level. And again, all those breaking up those workloads to smaller pieces also have overhead, and you need more servers, more copies of the OS, harder to provision. Okay, you don't enjoy resource pooling of different stuff, and you need to over provision every this subsystem now. Yeah, so
Interesting.
all that contribute to the efficiency gap when you run Redis based workloads and compared to Dragonfly based workload.
Got it. Wow. So essentially, you're saying AWS has just taken the plain vanilla Redis and just runs it in its own platform, but they've not really added on much to Redis itself.
Yeah, probably not completely plain vanilla, but it's a fork. But the core engine is the same.
Okay.
As far as I know.
Comes to threading, it's the same challenges.
Yeah, same single thread implementation, C language based implementation that is around for quite some time. Yeah.
Okay, cool. So yeah, tell us a bit more about Dragonfly's approach, and so what kind of language implementation have you chosen, and what are some of the design decisions you made that makes Dragonfly to be an innovative option in the space?
Yeah, sure. So as I mentioned before, Dragonfly takes a unique approach that and applies a multi-threaded architecture, multi-threaded shared nothing architecture, which means basically that every thread is in charge of one part of the data. Okay. So as long as you have single key operation, or your operations are localized to one thread, there's no synchronization is needed at all. But on top of that, Dragonfly implements a pretty novel transaction framework that allows cross-thread operations. Redis supports basically multi-key transactions, either in multi-key operations, or even supports multiple operations in a transaction and Lua scripts. So it's really a very kind of rich API, and Dragonfly transaction framework is able to support all those semantics of multi-key cross-thread operations with the same atomicity guarantees as the single thread Redis. Again, in a almost completely lockless fashion, which avoid, of course, the contention and performance issues that the typical multi-threaded software incur. Yeah, so that's the novelty of Dragonfly.
All right, interesting. Yeah, that's a great explanation. But even better than telling us, if you can show us Dragonfly in action, that would be great. I think you have a little demo prepared for us.
Okay, sure, yeah. So let me show in. Right. You see my screen? Okay, cool. Okay, so this is like the Dragonfly Cloud console. Okay. So before we go and like create a Dragonfly data store, because I want to like show like the most performant like setup. So Dragonfly Cloud also supports like private networks, meaning that you can create like your own dedicated network in Dragonfly Cloud and connect it to a VPC, okay, in your cloud account. So then you can connect to the data store over private IP space and have the like best security and performance setup. So in interest of time, I already created like the network and connected it. And now I want to show you like how easy it is to just create a data store. So I go with GCP and create a 100 gigabyte with enhanced compute data store, and I will choose my private network. And that's basically it. It will take a few minutes to provision, but yeah, you saw how easy that was. We can meanwhile like browse a few features. So we support. Yeah, go ahead.
Sorry, yeah, that's really easy and very simple. It's just a click. But what's happening in the background?
Yeah, so in the background, like our control plane is provisioning the hardware that is needed, installs all the software like Dragonfly and like monitoring agents and like control agents, and everything that is needed to run the data store. We support currently AWS and GCP. Azure is in private beta. And we um, we have like a bunch of security features. So we saw like for AWS, I don't have a private network, so I can select it, but we can also like connect publicly over the internet, and then you can control if you want TLS enabled or not. You can configure the data store to be like cache or never evict any item. And you can also specify multiple availability zones for your data store to be highly available. And then again, our control plane will monitor and fail over if necessary the data store. Yeah, so basically, all the features that you'd expect from from a database as a service product. Okay, so now our data store is active, and we can try to connect to it. Do you see the terminal?
Yes, I do.
All right. So again, like every like standard Redis client will work. Oh, so we start by using Redis CLI to connect. Okay, and like start Redis commands. Okay, and now let's run a quick load test to see like how performant is our data store. So again, like mounting benchmark is like a standard Redis tool for benchmarking. Okay. So you see, load test is running. We observe like over 1 million operations per second with sub millisecond, even sub half a millisecond latency. So yeah, with just a few clicks, we got here like a very performant in-memory data store running for us. We have some like built-in monitoring tools. So like also like Grafana based dashboards, and we also support like scraping metrics, so you can scrape and integrate into your own monitoring and alerting system. Like it will take a few minutes for the for the dashboard to have like more sampling points. But you can already like see the like get latency. That's like server-side latency, few microseconds, and like in a minute or so we'll have like more interesting data here. Yeah, let's see soon like the dashboard will match the over 1 million operations that we observed. Yeah, that's
all right, awesome. Great, thanks. Yeah, that looks really easy and simple, and importantly, it's performing really fast, and yeah, this can scale. So, what's the kind of scale we're talking about? How much have you tested this? What some of the like high volumes you've tested it against?
yeah, so like like benchmarks, we go up to like several million, like 6 and 7 millions of operations per second, and also like yeah, and also like some of our customers also like go to the extent of like 1 billion operations per second. In the community, we got feedback, that folks, are running like on like those 128 cores servers. Yeah, replaced, replaced like very large Redis clusters with a single Dragonfly server. Yeah.
All right, all right. Wow, that's awesome. Yes, congrats on your launch of Dragonfly Cloud. When was this? How long back did you launch?
So we've been like we actually like onboarded our first Dragonfly Cloud customer over a year ago. But we took the time to like onboard, work intimately with like the first customers and onboard slowly and improve the product, improve the control plane, perfect it, and like once we felt it's like mature enough, for people to go in and self register and self serve themselves. We open it for the public to for anyone to register and use. Yeah, so that's happened just like a few weeks ago, and
Okay.
yeah, and it's extremely, I think it's extremely exciting.
Yeah,
Like it's a huge milestone for us as a company, right? And
absolutely.
extremely exciting to to put our our craft over there, out there in the world, and like observe people actually using and buying and providing feedback, and yeah, it's just the beginning.
Yeah, yeah.
We are
Wow.
we're very much
Uh,
after like feedback and
mm,
continue improving.
yeah, yeah. And so for those listening, right, who want to move, they also probably are thinking about migration. Have you have you built in any features for migration to make it easier from Redis to Dragonfly?
Yeah, great question. So Dragonfly itself, it supports it supports replicating from a Redis server. It also supports the Redis snapshot format. Um, um, and that's like in terms of capability. In Dragonfly Cloud, it's not yet like enabled, and we help like customers that wish to import data. But we will soon launch a feature to import like Redis snapshots from anywhere into Dragonfly Cloud. Yeah, that's
All right. Okay. So,
definitely one of the requests we're hearing from customers.
okay. So it's in the works, but you do assist manually. All right.
Yeah,
Interesting.
for now, yeah.
Okay, cool. Yeah, so as we wind down, I just want to ask about your thoughts on what's next for Dragonfly. You mentioned, well, migration is going to be easier. Any other
Yeah,
interesting features or direction you can give us of what to expect from Dragonfly in the coming months, maybe a year
yeah,
down the line?
yeah. So I think like in the like shorter term coming months is like we've been working for the past few months on horizontal scaling.
Mhm.
So while we strongly think that like you should first vertically scale, okay? Because it has like lots of performance and maintenance benefits. Eventually, of course, you exceed like the capacity of a single machine, and
Mhm.
to like cater our larger customers, we need also to horizontally scale.
Yeah.
So this is something we've been already working on, and again, it's in private beta, but I'm very optimistic that it will also be open for anyone by end of this year.
Mhm.
So this is one thing, and also like in the last community release of Dragonfly, we announced alpha support for data tiering, which means that you can like extend your memory capacity using SSD. Okay.
Okay.
Um, and also like you and like it's about like intelligently offloading some of the items into SSD while maintaining those requirements like latency and throughput requirements for in-memory workloads. So it will take time to mature this technology, but I think it's a good like testimony for again how Dragonfly we strive to really make the most out of the hardware, okay, and like how our core multi-threaded heavily asynchronous technology allows us to build more capabilities to utilize modern hardware. And yeah, so this is like something to expect next year.
All right. All right. Wow, really interesting. Horizontal scaling and data tiering. You should come back early next year and tell us once you launch those and give us a
So
demo of features as well.
yeah,
Um,
with pleasure.
Ari, I just wanted
Uh,
to get to know you a bit more. What do you do when you're not
sure.
working, or what would be alternate career path if not for your job in tech?
Okay, nice. Um, so I mean, I very much enjoy like sports and mostly like high adrenaline sports like kite surfing and snowboarding. So maybe in an
Me,
alternate universe, I would be like
me,
extreme
venture.
sportsman. But I really enjoy like building software. So I
Yeah,
don't think I would trade it.
great. All right. Thanks for joining us, Ari. That was a yeah, wonderful conversation. We really dug deep into what in memory means and even just your approach with Dragonfly and how you guys are on this journey of creating a unique product in the space. Thanks for all you shared. There's quite a bit of interesting stuff in there. Do join us again when you launch something new.
Right, with pleasure. I enjoyed it very much, and thanks again for having me.
Right. And thanks to all of our listeners as well and our viewers for tuning in. We hope you enjoyed this conversation, and we'll see you on the next one.